A car is travelling along a straight road. It accelerates uniformly from rest to a speed of 24 meters per second and maintains the speed for 6 minutes. It then decelerates uniformly to rest. If the acceleration and the deceleration are 4 meters per second squared and 8 meters per second squared respectively, find the total journey time and the total distance travelled during the journey. So we're going to do this question two ways. Method one, we're just going to use a graph. So if we draw a set of axes, time and meters per second, and this is just a rough graph, so it's not an accurate graph. It accelerates uniformly, so it will accelerate to this point here, t1. Then so that's 4 meters per second squared. Then it travels at a constant speed, this point here being t2, and then it decelerates at a faster rate than here. Then we get t3. Now what we've got to find is t3 for the first part, and then we can find the area underneath the graph. So acceleration is speed divided by time. So if we rearrange that, we get that t is s over a, which is going to give me that t1 is going to be 24, because it goes 24, divided by the acceleration, which is 4, which is 6 seconds. So t1 is 6 seconds. Now the next part of the journey, we know, is 4 minutes. Now 4 minutes is 4 times 60 seconds, which is 240 seconds. We have to have consistent units. The last part of the journey, so this distance here, this time here will be 240 plus the 6 seconds initially to give me 246 seconds. The last part of the journey, T3, T2, i.e. this time here, will be found by taking the speed, which will be minus 24 divided by minus 8, because the acceleration is minus 8, and the speed is, we're using velocity here, so the velocity will be going back towards in the negative direction. So that will give me 3 seconds. Therefore, the total time will be 246 plus 3, which gives me 249 seconds. So the total time for the journey will be 249 seconds, or in minutes, 4 minutes and 9 seconds. And I'll show you how to work this out later. Now, the total distance is the area under the graph. So this is a trapezium, so we need to find this length and this length. So it's going to be, this length here is 240, and this length here is 249. We need to multiply it by the height, which is 24, and divide by 2. And that will give me 5,868 meters, or 5.868 kilometers. Right, now if we use the Suvat equations, and I probably think the graphical method would probably be the easier of the two. Stage 1, the initial acceleration of 4 meters per second squared. We know that u is 0 because it starts from rest. We know the acceleration is 4 meters per second squared. We know the final velocity is 24 meters per second squared. So using v is equal to u plus at, and we're calculating t, which will be t1 on my graph, will be 24 is equal to 0 plus 4t, and therefore t will be 24 over 4, which is 6 seconds. The distance travelled in that first part will be, we can get from, or the displacement we can get from ut plus a half at squared, which is going to be 0 times 6 plus a half times 4 times 6 squared. So this bit 0 and a half times 4 times 6 squared will give me 72 meters. In stage 2, a constant velocity of 24 meters per second, u is 24, and then the final velocity at the end of that time period will also be 24 because the velocity is constant. The acceleration is 0, but we know the time to be 4 minutes. So the time in seconds will be 4 times 60, which is 240 seconds. And using S is equal to U plus V times T over 2. So that will be 24 plus 24 times my time for that period, which is 240, divided by 2, which will give me 5,760 meters. In the final stage, stage 3, the final deceleration of 8 meters per second squared, U is 24 meters per second squared. The final velocity will be 0 because it comes at rest, and A will be minus 8 meters per second squared, minus because it's a deceleration. So we've got V is equal to U plus AT. So 0, this will help me define a value of T. 24 plus minus 8 times T. So that gives me that T is minus 24 divided by minus 8, which is 3 seconds. And then again, using S is equal to UT plus a half AT squared, we're going to have that S is 24 times my time of 3 plus a half times minus 8 times 3 squared. So that will give you 36 meters. The total time is equal to 6 plus 240 plus 3, which is equal to 249 seconds, or 4 minutes 9 seconds. Now you get the 4 minutes 9 seconds by doing 249 seconds, which is 249 divided by 60, which is 4.15 minutes. So what we're doing, we're just going to convert this, show you how to get the 4 minutes 9 seconds. You do 249 seconds, 249 divided by 60 seconds, because there's 60 seconds in 1 minute. That gives you 4.15 minutes. Now the 0.15 we convert back to seconds by multiplying by 60 to get 9 seconds. The total distance is going to be 72 from the first stage, 5,760 from the second stage, and 36. And that will give me 5,868 meters, or 5.868 kilometers. So this has been a video to show you how to find the total time of a multi-stage journey and the total distance travel using two methods, a graphical method or the Suvat equations. I hope you've understood, and I thank you very much for watching.